Somehow I don't receive any messages to my chat system. What's going on? I can hear Twitch, but I can't hear YouTube. What is happening? Did YouTube change anything? Yeah, TTS. It's only YouTube. I don't know. It's weird. Let me check. Yeah. Hey, Jordy. Hey, Sonic. Let me check. So exhausted today. What is it? Pop out undefined. Oh, Johnny, your plugin doesn't work. YouTube Live. I don't have the right ID there. Or did I break it? I don't think so. Let me deploy. Oh. So authenticate. Now it works. Hey, Basil. Okay. Yeah, I didn't use the plugin to retrieve the ID. Now it's working. All right. I have a coding session of now about 12 hours behind me, so I'm really exhausted today. As you can see, there is nothing behind me. What happened? Yeah, but you got a really boring stream because there is nothing here. Hey, Dutch maker. Look at that. Nothing. There is no lab. What? Yeah, I'm moving the lab. And that's why nothing is here anymore. It's next door. Bitluni. It's next door, and I have like 50% more space and more shelves and everything. And already the Ultra cluster is over there. But I was spending a lot of time the whole week basically coding, because there have been like issues, difficulties. You remember maybe flashing the CH570 wasn't like straightforward from SRAM, because one of the functions of the library that they say you should use even in the data sheet. So there is no, I can show you that. There is no, if you go to, it's basically the reference and technical reference and data sheet in one. It's not like on the other ones. Usually you would have the CH chips, you have like a data sheet with the pinouts and then a reference manual. But this is 2-in-1, and if we go to, where is it, flash. Where is it? Huh? Let me just search for that. Come on, where is it? Flash ROM, flash control, memory mapping. Wait. Hey DFJ. Am I blind? I might be blind today already. Register this. Yeah, here it is. Wait. System control. Save access. Okay. No, that's not that. Here. This is what you get in the datasheet. Please refer and call related subprograms. No description whatsoever. Alright, so it's a mystery, and Basil also helped with disassembly, and I had like the two disassemblies. Basil's disassembly was better than mine because, I mean, in my one there were the actual absolute addresses, which was better, but the Basil's code was more readable, so we just threw the .a archive into a disassembler and it spit out some C code, some pseudo C code and assembly and so on. So what I did, I tried to re-implement like the minimal steps that you need, like to erase a page, and use Gitra. What did I use? I used like an online page where you can use all the disassemblers, and most of them failed except for like 2 or so. So I copied that code. I tried to implement that, and the issue with the CH570 is it doesn't have like the flash where the code sits. It's like on an extra die that's attached over SPI internally. So every time you try to access the code or whatever, it will read from over this SPI from the flash ROM. Same with like constant values that are mapped into the memory or whatever, constant value section, and so on. So it's really hard to debug, especially if you try to write the code at the same time. Debugging while having all the interrupts disabled and everything messes with stuff, especially because the debugger reads out some memories to have, like, if you have watches or a memory view or whatever, it will update those and try to read like from memory. It's really hard like to not mess around, and usually what happened is it just locked up whenever either it didn't break, it didn't trigger any breakpoints, because these are also interrupts, or it I don't know exactly how the SWD debugger interface works. I didn't look into that too much, but what was happening basically, you couldn't debug the code at all. You just ran the code and saw the result, and most of the times what happened is it locked up, the chip locked up, and you didn't see anything. You can just restart and see if something was written in the flash, if it was like erased or anything. and most of the time it wasn't. So what was happening is that actually we were able to clear or erase a page. You need like to erase like 512 byte page before you start writing to it, rewriting it. Weird enough, when you erase it and you read in, it's not like there is FFFFF whatever. The values are like really odd, like AD blah 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 blah. It looks like maybe the memory is like, I don't know if there is some parity in or whatever, like extra bits, but it looked really weird debugging that. But erase was working most of the time, and what I tried to do, like I couldn't make the flash work at all. Like, hey Gwindor, I tried to write the bytes or whatever, didn't work, and then I tested with Gemini. Gemini was interesting. I asked Gemini, the thinking model, to like, yeah. So what I gave it the code, the Basel code. I call it Basel code, the Basel code and the Looney code. I gave it like just all the whole code, and said, all right, this doesn't really work. Please check out how that works and give me like some minimal code to erase a page and write bytes to the flash. And it actually tried like to understand the underlying flash controller, which is like a standard flash controller, more or less. WCH is the manufacturer that you can like pull like an ID that gives you manufacturer blah blah blah. I'm not very familiar with that standards, but that's how that seems to work. And yeah, default function codes that you can send. You send like a command and then data, whatever, and the flash controller does things. So it's like you have like an extra SPI controller within the MCU, which isn't documented. That's like registers that are like in the middle of reserved memory area here. I think, let me check. I can show you the resulting. Yeah, I think it was like here. Was it here or was it here? Like some reserved area. Basically, there is like the peripheral for that. And Gemini understood what's happening there, and let me check. Let me check this one here. Level 0-bit bootloader. Can maybe show you. Okay, so it pulled in like it made it interestingly. Make it big too so you can read. Pulled in some defines here. That's the area. That's not the prepare safe access flash. I think here this is the flash controller. Also the flash control is same as flash status, I believe. Yeah, flash ready. Yeah, it just pulls flash control. And I did all that like in SRAM, so all the functions are re-implemented in SRAM. And yeah, what Gemini really understood how that works, and I tested it. It didn't work at first. It was like it had like an extra byte, or everything was shifted. And it's quite interesting when I tested with the get ID. I think I erased it already. Streams verification pipeline. No. So there was like I tried the command to get like the vendor ID, chip ID and everything, and that data wasn't like correct. There was like an extra zeros in the beginning or whatever, and what I did, I took the byte stream and gave it to Gemini and said, this is what I get, does it make any sense? And said, oh no, it's shifted, there is an extra byte, and fixed the code, and was like a back and forth. Long story short, in the end, it was like the flashing code, the erase code was working perfectly. So the first goal is that if you launch the function here, let's say here flash erase 4 kilobytes, that it enters the function and then returns afterwards. That's like this is step number one. You got like the majority of the way. Hey, life. Majority of the way if it even returns like in your debugger, and you can see what the results are. So during debugging you can check the memory and see, alright, okay, it was erased, and I was using the library functions that are not in SRAM to write some test pattern in the memory, and then erasing it with this function, and actually wrote I was like suspicious. It was suspicious because it wasn't like FFF whatever. It was like this odd pattern, but it erased, like overwritten all the bytes. All right, that was step number one. But then like writing bytes, it had like it wasn't writing the data that I was giving the function. It was writing like some other bytes, and I said, all right, dude, to Gemini, it's writing some garbage, and I get some garbage, not like the actual stuff that I'm writing. And I copied the bytes from the memory and gave it to Gemini, and identified, oh yeah, it's the control bytes from that we sent before and so on, and they are buffered and whatever. So it understood where the bytes are coming from. And but I wasn't able to figure it out what the issues were. So I tried different step after digging around for, I don't know, half a day. I tried ChatGPT. I wanted to try Cloud Code, but it was Friday and it was like fully, like you couldn't access it free. So I went back to ChatGPT and tried using that. It had like completely rewritten the code, and it looked all right and basically similar to my implementation. And it was always like hanging where flash erase was working. It was only hanging in like odd situations when I used the library or not, and it was like really weird. So there was like a state that was wrong, most probably. But flashing also didn't work, and I was trying to fix that code for another half a day or whatever. In the end, I thought, like, I was totally worn out. The next day, then was Sunday, I thought, okay, so Gemini at least, hey Jesse, Gemini at least was able to write any bytes, and it was able to return to my code without crashing. So I thought maybe that's a better way to handle that. And it was like a matter of like, sometimes you need just to go like after 12 hours of debugging and you're totally messed up, like going to sleep and trying a new approach next day works. Like within 20 minutes I made it work with Gemini, because I checked the code again. I thought, oh well, and it worked somewhat. It only was writing the wrong values, And what Gemini did is it tried to push in over the SPI, it tried to push in individual bytes. But from what I know about this flash controller, it only supports double word writings or writes. And yeah, that was the fix in the end. Just asked, I think even there was already Gemini already like prepared the function for writing double words, but I never tried them. And switching to that, everything was fixed. The only thing that you oh yeah, give LLMs SDK context. So I would what's the IDE that you there is like this special IDE that what's the name that uses like built-in LLMs. I forgot because I'm using I'm paying for like that anti-gravity, maybe, I don't know. It was a long time ago. That can probably access all the files. Cursor, yeah, it might be Cursor. Cursor. Do I have Cursor somewhere? I don't know. You can see. Yeah, but I'm not using that. I usually what I see is now Gemini never expects. Oh. So my experience with Gemini is it pulls the information from the webs. I have like some stuff like what I'm trying to do right now is like switch my code to DMA transfer, like the data on the bus of the ultra cluster. Currently it's just like pulling values like the SPI. It's not great, and there is no upstream yet. Big problem. I need like to communicate stuff back, and yeah, that would be best with DMA. And in that case, it also gave me like some weird. JC parts plug into Claude? What? Huh? What? Okay. Yeah, anyways, most of the time, I mean, it's like coding with, I just use like the browser window right now, and it works really alright. It's good enough, and sometimes I know already, yeah, that code wouldn't compile, but then I just check the SDK. All right, that's the function, or I complain to the a TUI is worth a try. What is TUI? Terminal UI. Yeah, I don't have time to try that stuff. Dudes, I'm coding all day long to try fixing all the issues that we to finalize our thing. The hardware of it's almost done. I just got some cables today that I ordered last Thursday. No sound. What? No, it's you. It's not me. Yeah. Okay, so here, because we were short on cables, that's like the 12 volt high voltage, high power, whatever connectors, and on the other side, 2 6-pins. So I have 4 of those that we can connect, but these were, I bought them in white because white was listed as it will ship until tomorrow on Amazon, and it took them 6 days. So I could have get like I don't know, black ones or whatever, but it's all right. Oh yeah, you can make it pink. Yes, I have 4 of those, and I have some other cables as well. Um, yeah, I also got like thermal pads and to replace the paste if we would want to do that, but that's nothing that's very interesting. And I have like still some coding to do. So basically, there's nothing to do except for programming the blades with the firmware that will be able to flash itself. And that's what we are working on. And I mean, we have like the old code that I already erased. I mean, I checked, I have like a Git. I made a Git commit for that. Yeah, that's how it looks like. I bricked my test device here, or I didn't brick it, I broke it. It restarts every second. I have no clue. I get like a boot loop. I don't know if it's the crystal, it's something, it's not stable anymore. I was coding today, this was where I was testing my flashing stuff. I don't know if it's an issue with maybe the flash worn out, because I programmed it like 100 times or 200 times, but it usually has like 10,000 write cycles or 100,000 write cycles, so I don't know. Anyways, my test device broken. So I had to switch to no, it is booting, it's running, but after a second it just restarts. It always like restarts after a second, so it's not stable. What I managed to do though is so I thought, all right. So what I'm testing is but I erased the complete chip. I reset everything, and still it's I saw similar behavior when the crystal wasn't right. So I don't know, maybe something's off. I don't have the time to like, because I'm moving the lab. I also don't have the space to like change the chip. I can just swap it, so I can still use the board. However, yeah, this is the USB. I have a working firmware that communicates over USB to SPI, and this is, you can maybe remember our test row that receives also SPI and forwards SPI to the individual MCUs. And what I managed to do today with one issue, I tried to program this MCU whilst this one was connected, and it somewhat bricked the MCU. So I switched to this one right now. So this is the one that I'm testing the communication with, and seeing here a white glowing LED is a success, because that means that all my bus rewrites and everything what I did there is actually working. Still, I need to change everything to DMA and do the upstream. So maybe I can show you. Of course, I made some tools. My work with AI is usually, oh yeah, just getting tools here. This is also Gemini. Did a perfect job here. So what I do with that, Usually they're like, I think hex to bin, but I wanted to analyze that in HTML, so I can just take, let's say, the firmware here, drop it, and I see that was like also Gemini. And as you can see, that's interesting. It has probably two sections, and this is most probably just an initialized variable or constant section. And this is only like skipping a few bytes or whatever to get like an alignment of 16, I guess. It looks a little bit weird, but I told it, all right, make it monolithic, and it just fills the gaps with zeros, which is really cool. And I can just download it, and it downloads the file with file name is the start address, which is 0 in this case always. So that's just a tool to upload the firmware over like to the cluster later to update the MCUs. Yeah, I mean, today is the first day where when I noticed one thing. Usually, like, I try to find tools, and I even finding them on my hard drive. Hey, Roman. Got nice GUI, yes. And you know what? This was I can show you the prompt for that. Here. That's my maybe you can see whatever I'm asking it. So basically this is what I gave it, like one sentence. It's like a Google search, and it gives me, add option to creates file spanning the range from lowest address, filling gaps with 0. And that's the updated code and nothing else. I didn't need anything. Oh, wait, did I? Drag and drop does not work anymore. Okay. Okay, there was one fix that we needed. But this was this was like easier than looking in a forum somewhere or whatever in on the internet. I'm at a state where I get annoyed when I type something in Google, it doesn't automatically run the short like AI mode thing where it like consolidates the information and gives me. Usually when you ask it as a question, like the Google, it will just switch to AI mode and then give you some more search results. And now when I don't trigger this AI mode, I get annoyed. So old school search is almost dead, I'd say. I'm not even like, I'm too lazy to look on my hard drive if there's like a hex to bin. There is one hex to bin, I know, because we needed that. Yeah, classic web is dying. I don't know. I mean, there is still like the sites that you regularly visit. Yeah, they are wrong. Yeah, that's like always. You need to be critical about that, of course. But it also gives you short links, like in this AI mode, gives you links to the sources of the information. So basically, most of the time I know what I want, and when I look at it, I know it's correct or not correct. I'm just too lazy to write it down myself or sit down and look for the sources that I have somewhere written already. I just like that. Too lazy to look. I will just generate I'm contributing to global warming right now. I need to install more solar panels to compensate for the energy that I'm wasting using AI all day long. But it shouldn't be that many kilowatt hours. Oh, you managed to do that? Yeah, then it's very specific, Pacer. Radiation in the compute, yeah. All right, the other tool, I wanted to show you another tool. Where is it? Not this one. Where is it? Yeah, here, my web control. All right, this also Gemini. I just modified it because it was like some define word. What do you mean, DFJ? I don't get it. Give me an example. All right. So this also. Oh, dictionary. Okay. Yeah. This is also with the help of Gemini, but I added stuff. So it's not all. It's not all the base with UI and everything. I think it's even connected still. Yeah. So what I can do is, let me show maybe the camera. I don't know if it's still active. I might have messed around. Oh, okay. Yeah, I understand. All right, so this is the comment byte. This is the target address. Okay, you can see that's too small. Here, let's go like that. Hey TMK. 16 byte packets. But I thought this is the FIFO size of the CH570, but the FIFO size actually is only 8 bytes. So the message I don't know if I redesign the bus, but what it's doing, like this is the comment byte. I changed everything. You remember when I gave length, then whatever. Yeah, I thought, okay, let's make it simple. It's always 16 bytes. We have comment, we have start address. We have no. So we have target address, we have source address, then we have payload size, which is always 8. Or you can put checksum there. It was just an odd byte, and then the data. Here you can see FF. That's like color, and in that case, this is like application comment, and if I send it, it changed it to blue. You see that here? This little LED. Let me zoom in. So that was routed. We can change it to purple here, boop, or red, boop. Here we go. And there is like interesting stuff because I implemented a bunch of commands, and this is like level 4. The MCU level 4, it's going down to level 0, so we have 5 levels, and this one has already like talking back implemented because that's going over USB, so I didn't need to do it over SPI yet. But what I have, I can poll information like 71 hex is get status, and what the get status does is it's just 8 bytes of information that can be used like printf or whatever. If I send that, bloop, it will respond. Here you can see Rx. Then the highest significant bit is set, so 71 plus 80 is F1, and this is the target, this is the source, and this was the other way around. So what the bus is now capable of is addressing every other MCU as a target in the whole cluster. So it's not only communicating between the host and the MCUs. That would be simpler, but I did it overcomplicated. All the MCUs can communicate now. They just push out a message with in that case, if it's responding, "Hey Foo, thank you very much for the super sticker." So if it gets like a poll, oh, give me the current status bytes, it sends it to basically to level 4. The 8 here is the terminator. So usually you have 6 bits per level, and anything above 32 isn't an MCU that's a lower level. It's a terminator that indicates, oh, we reached the final level here. So that's why. Oh yeah, it will be too slow. There is a broadcast though. So what we can do is we have like if instead of sending like only like the highest significant bit for terminator, we can broadcast to the whole level. So if we would and the heavy load is done by the MCU that's on top of that. Like all the clients, if I say a broadcast to all the clients at this level, it will terminate at this from this level on, terminate at the MCU and broadcast downwards. It's not implemented yet, the broadcast, but it's one color for all. Yeah, no, that would be for like uploading your Flash firmware. That imagine that if you Flash like have to upload 8 kilobytes every single MCU, maybe then polling, I don't know, verification or whatever to be sure before the Flash process starts. Yeah, that will take some time. So broadcast might be useful there. For the Ultra cluster, we have currently only 8,000 LEDs. So USB speed should be enough to have like a good update rate. I don't know. 16-byte packets are quite big. We will see. There's always always space for improvement. If we upload it like only one way, no bus system that communicates, like in that case you could let it communicate and do neural nets that have like connections to everyone and calculate like tensors or whatever. If we remove that and we only communicate in one direction, or then we only need like 6 bytes or and that times 60. Yeah, that's good enough. You have like what is it? USB is, I guess this will be like 40 megabits or whatever, 40 frames per second, then more or less 30 with overhead. Is it? Yeah, 40. Yeah, 480 is USB full speed. Using, wait, let me check. Okay, let me check. We are using level 4. Level 4. Oh yeah, I have a good simple CDC implementation now. Also, AI also helped to clean that up. Hey, Flyken. Because it was like the code. I did it so often in the past already. But it was like there is only like an example that does emulate actual UART and everything is entangled. So it's not like implementing abstract CDC device like I like here. It had like all the UART code within the endpoint code and everything, which is terrible. I see, Flyke, and you have some fun. Anyways, this is USB full speed. Full speed? I get always confused. High speed is, I think, with extra. Full speed USB. Ah! Uh-oh. Yeah, we need to scale down our stuff. Then. Or we let the MCUs calculate the output. Are you kidding me? What? Did I use the wrong interface? Oh, you're right. Oh, wait. What is the high-speed controller though? It doesn't have a high-speed controller. Oh no. No, it has high-speed controller, but do I use the wrong pins here? Oh no, maybe I need a botch to use high speed. Wait a second. Nah. Nah. Nah, we have two peripherals, that's the issue. What are you... This can't be... Wait, 16 bytes. 16 time wait. One megabits. No, it's 1 megabit per update. So we have 12 updates a second. With 12 megabits. Times 60 watt. No. No. Yeah, but it's still a bummer. So let me check. USB. I don't know if it's. That was a misunderstanding. Okay. Yeah, usually 60 FPS is what you're aiming for, but. I have to check. The bot would be easy, but then I have to rewrite the code and fix that. Botching is easier than code rewrite. Let me check pin definitions. Okay. Full speed, high speed. Wait a second. Both the same. Full speed is A pins. Oh yeah, I'm using those. PB 6 and 7. I think they are free. I can just switch to those. Huh, interesting. How many MCUs in the full cluster? In the full cluster, it's 65,536. So that in that case, we need certainly USB 3. This is like we have built with only 16 blades right now, but there will be another build with 64 blades and another build with 128. That's the full build. The 128 blades has, and the build with 16 blades has 8,000. All right, high speed. Oh yes. This MCU doesn't have high speed. So yeah, we're stuck with that. We have to do whatever we, yeah, there is no, and yeah, I don't need to do anything about that right now. That's it. Ah! What was it, 10 frames? We make it 20 if we transmit data like that. Oh no. Maybe we need to make it more compact. Consolidate, let the MCUs, the levels, consolidate the information into more compact packed data. Like if we do yeah, this is the actual amount of bits. So if we can do 12 megabits, yeah, but this is like I don't want to use the USB 2 for the full build. We need like to switch the base anyways, and that will use FPGAs and either directly from FPGA USB 3 or from another controller that is capable of doing that. Let me calculate. So times 8. That's we can times we can do 8 FPS if we just send raw data from the full cluster. Yeah, that's basically what I think. Just everything packed, and the MCUs process the binary data and distributes it. Anyways, yeah, 12 megabits is not that fast. Oh no. I'm wondering if I can if the footprint, but I think the footprint isn't compatible of the 3.7, because that one, let me check the come on. Wagon loads. 3 VTC 7 RTC. There is a pin compatible. Wait a second. I can just switch the MCU to have full high speed, which will solve some temporary issues. Not 17. RCT, that's the one. Okay. Let's see how compatible that is. Yeah. Wait. I have the wrong tool. Here. I guess they are pin compatible. The only thing that is different here, that's the LAN connection. And yeah, and PB6, PB7, USB. Wait a second. It should have the same. It doesn't list the USB on the B ports. Yeah, it does. RCT. USB 2. Nice. Okay. Yeah. Maybe I will switch the MCU and then we can have some extra. Should I just order it? 480 megabits. Yeah. I don't think that my wiring will be sufficient for that, especially if you look at here this USB. Yeah, this I mean it will be directly connecting these cables like to the MCU. What that looked like. Yeah, so I don't know if that will work. Maybe okay, let me get that IC first. So I need this one here. Yeah. Oh, you're right. Yeah. If we twist them, a differential pair. Yeah. Okay. Can I get it from eBay locally? Whoa! What is going on? Yeah, I don't know. And $3. $3 here. Yeah, blah blah blah. Yeah, I don't need it badly. Nah, that's that. I didn't buy that one at all. Okay. All right. Yeah. Never mind. Let's get it working at all, and then we can optimize later. I can always just connect another dev board to the base board, because I made I attached the bus. I made like a connector that attaches to the bus, and we can always just listen to the bus from I have four. Yeah, we can use ASB. Level 3. I didn't test yet. It's only 6 megabits. 7 point blah megabits is I think what we can 7.5 megabits is what I can drive. So it's not that fast. That would be the limit if there wasn't like an extra 16-bit parallel bus next to it. That's the limit. So actually it's, what is it, 150 megabits is the actual limit. Anyways, yeah, let's try doing more productive instead, less talky. Oh, I'm so tired. What I wanted to do is switch DMA code. So we are working on level 1 currently. We are doing, oh yeah, it's debugging. So what I changed right now is, beforehand we had a basic polling method in the main loop that was just reading. There is not even a FIFO on the 303. We are just polling the data in here, receive data blah. So this was what we are, okay, this code is too small to read for you. What is this debug? Let's move it to the side. Can I just change the size? I can't make it smaller. Okay, yeah, I can get rid of this temporarily, or close the disassembly. I don't need it anyways. So what was happening, we were polling that, but the issue is you don't know where the message starts or not. So I added the interrupt handler for chip select, which is pulling low when it starts, and then it triggers the interrupt. And what it does is it reads in the bytes, 16 of them, but if the line goes high before we finalized reading 16 bytes, it just returns from ignores the broken packet and leaves the handler. So I need to drink. What I would like is to replace that by DMA code. I did DMA code in the past. I'm not sure if it was successful, but we have now a comfortable method of testing that, because even if we don't debug, we can always turn on, like use our tool to switch LEDs or whatever, because like debugging within interrupt is always critical. You might miss stuff, so that's that. Is there something else that we wanted to do? No, I don't think so. No, the communication is webcam LED, the binary converter optical debug. Yeah. You're right. No, we don't do it. Let's be constructive. So I had, yeah, now it will open SPI, was probably startup SPI. Yeah, it opens this. I don't know what is weird. Okay, so I actually have a working handler, but there was, that's the DMA reset DMA. Now I have also here this example. I'm wondering if we can just test that. I think I will check in all my changes right now. I have to interrupt on both MCUs. All right. So now we have a working state. What I can do is I have super basic code by Gemini. What we can do is replace everything and see if we can receive messages this way. So what I will do, I will just rename, I will just add a file, new file, C, and I will add the code. I will exclude from build, and I think it will work. So what this does is I asked it to do basically the downstream and upstream, and for now we want to do only one direction, which is SPI number client. We want to listen to the client. SPI client is SPI2. SPI2 on the pins 12 and so on. So this is SPI3. I think this like JTAG, this is like this is not WCH, that's STM code. SPI3, wait, client, here we go. We need the clocks though. Okay, client. NS hard via hardware interface plus blah. Okay, that's that. Then we have DMA. Oh, wait a second, SPI. Oh no, we have here partial stuff. Need to check if it doesn't remap hosts. Yeah, we need to add that. Wait, floating. No, that is all right. It's interesting how it combines also two pins. SPI3, SPI. So that's interesting. It just does that. I don't see any configuration. Oh, it reuses the stuff here. So we need to do basically that. Slave hard NS mode. We just do that and do that. Oh, wait, no. Better like that. No, it's not fixing. I'm just removing parts that I don't need right now because I asked it to do all the stuff and I want to test bit by bit. Client, DMA, SPI3, DMA comment. That's interesting. You can initialize DMA for both directions at the same time. SPI enable. All right, DMA channel. That's interesting. It enables SPI before it initialized the DMA channel. Might be necessary, but DMA, that's SPI3. Yeah, we need all the shenanigans here. Okay, it stops DMA init. DMA init. We just need to initialize those. Channel 4, 5, SPI2. Now it also uses start detection, that's the client. You know what's interesting? I asked it using client and host, and it also uses client and host and not master and slave. So either it took my definitions how I asked, or it is aware of those. It's Vogue. Trigger falling. IRQ. What is PC? What is this short for? What does it stand for? PC? Politically correct. Okay, yeah. Alright. Yeah, political correctness. Yeah, I don't know. I'm not familiar with the abbreviation. Yeah, that's the interrupt. Host transmit packet. We don't need that part. Interrupt handling. Oh yeah, alter Vogue. And config SPADMA pins. That's the packet. Transmit packet. Test cycle loop, interesting. And it does the transmit here. No, we don't need that. We can do, interestingly, if I do while and put the semicolon to here, it spits out a warning. It requires me to put it in a new line, which I like more or less. I mean, I'm aware of how that works, but it's probably better for other people to notice. I mean, I had probably some occasions in the past where I missed that semicolon at the end of the while or whatever. But wait, oh, that's the handler. What does it do? Vertical space. Realign counter, packet size. Okay, yeah, but okay, we can just add that's cool. We have the transmission and receive in one go, which is really cool. We verified the line. This is also good. Data counter, okay. Yeah, but I guess I will restart channels. They're now primed for incoming host clocks. Alright, so we want it here. Oh, we are still in debug. Interesting. Okay, let's do that and see what happens. What? Look at that. It compiled and uploaded just like that. Oh wow. Okay, let's test if we receive any packets from our host. Yes, this is annoying. The file is here. Okay, let's see if we get anything over DMA. We should, where is it? Where's my tool? Here. Let's send this here. We can easily recognize that. Boop. What? No, 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 no. We received something. Okay, let's check. Let's check what's in the buffer. SPI2 receive buffer and add this to watch. Oh, I have quite some watches here. Let's clear it and nothing. Oh, add to watch. Is there like a peak? Nothing there. Wait a second. Okay. It's 0. Wait, let me check which direction that goes. Can't make it. It doesn't fit. I can't. Why can I can't move it. It will close completely. Right. Then I close it completely. Trigger falling. Oh no, that's the wrong side. If it's primed. Oh, wait a second. Okay. When it's triggered, when it's falling, that's the start of the message. So let me check with the DMA again. Turn off to clear up state. Okay, but how do I know that I received a message? I need also basically either a DMA interrupt or I need an interrupt also on rising edge. I would usually reset everything. Hey Tixel Geek. I would usually try to reset everything on rising edge because the timing is quite there's no hex code here. It's so small. Can you even read? Yeah, I hope so. Okay, you know what? Let's do that. Let's run it. Now we probably missed the message, so let's send it again. And send it again. And then we will pause it and peek the contents of SPI RX buffer. Yeah, here we go. The message is there. Yeah, that was easy, huh? And it's aligned, everything is all right, but so what would be the best way of trying to bottom of the white page, what? I mean here? No. Here is also hex code, everything is hex. Yeah. And what would be the best method to trigger like get the message out? So when CS is going high, I think that would be, or DMA goes. Okay, I need to reset DMA on when it's going high. How do I detect? Oh yeah, I can detect the edge. Detect the edge here, so let's do that. I would rewrite the code slightly. Oh. It's now my code. Okay, so we know that we are okay. Oh wait, it is actually, it's double checking here. So we have even like the read. I will split it. Falling edge, enable DMA, or yeah, we can also we leave it like that, then DMA command, turn off clear up state. We do that at the end. DMA clear flag. And now we have a little bit more time. Realign counter. That's interesting. So it looks like we could, on falling edge, we could do just this here. Just reset to 0. Turn off client DM. What? Hey, Caspar. What? What? Yeah. Huh? Which line 177? Oh no, this is resetting on the start of a new message. It's because that's the falling edge. Falling edge, like chip select is always high, and it's the falling edge happens when the message starts, and this is what I want. I want the rising edge. That there is message. Here's the message done. Yeah, I know. This is basically what I want is um, I want that. I want here because I don't want to do everything. I want to prepare it um, before like we get on the start of a message. I want DMA to be ready already, and then I can do stuff after the message because the host will be busy with something else. So what we can do here is, okay, we can put everything there, but I'm worried that the initialization, that we will lose the first packet when we do this. No, we want everything. I'm wondering if we get the message here. Okay, so basically message done. Yeah, we should test. Oh, wait, let's do that. We can check the message here and how's it I control CS during sending, so it's always you pull it down, you do all your transmission like of all the bytes. Since SPI, you have the control, or the peripheral has the control over the clock, you can just keep it pulled down as long as you want that peripheral to stay active. But we could send like more than 16 bytes. We can like continue sending and sending. But I want like to keep the buffers short. So my limit is now 16. We could go longer or shorter, whatever. And usually you could send even more packets without doing like the shenanigans with the CS and whatever. But there is always like the possibility or the probability increases that you get some data failure or shift, or you miss a clock signal or whatever, then I have a bit shift. So using like triggering CS between each message, like pulling it down and then releasing it after a complete message, is quite good to have a good point of where to start. So I don't need to detect where a message starts with a tag or anything. So yeah, that's my indicator for a new message right now. I don't know, maybe we can do more. We can do more. All right. That's that. Okay, let's finished. The interesting part is I want something to be transmitted when I do. So it's like full duplex. So you need to fill the buffer in between messages. You need like to fill SPI to TX buffer with the message that you want to be sent on the next incoming message from the host, which is really weird. All right, but currently it looks good what Gemini did there. We will try the other code as well, and then yeah. Okay. SPI. Wait, that's the transmit buffer. Yeah, let's start. It's uploaded. We can. Play. And then let's send it. Didn't trigger. Oh yeah, not falling edge. Doesn't trigger on falling edge. There is a problem, or what is the problem? I can stop. Where? Stupid. Where is this? Huh? Ah, yeah. Tabs and spaces mixed or what? Now I get this in C. Oh, weird. Alright. We are missing trigger falling. We want falling trigger and rising. I have rising wrong here. Rising, not raising. Okay, let's do that. Rising and falling edge. We can handle both. Yo. Debug. Sultanas? What? Here we go. And did we receive? Yeah, here SPITX. Raisins, yeah. Here we go. Wait. I see only the first byte. Racing. Yeah. Okay. A Y. This is weird. Okay. I'm wondering if this was... Okay. Let me... I guess we just missed the first message. Now it will... Yeah, everything... Oh, no, there is a shift. Look at that. We have a shift by 1 byte. Oh, this... No, wait, huh? Eight. Address, yeah, there is a shift. Okay, let's try again. Because now it's reset. It's again. It's weird, huh? octal stuff here. That's so weird. Into disassembly. So this doesn't work. Okay, my guess is CS goes high before, no, yes, no, before DMA is done. And that's why we have like one left over, and on the first time it's not initialized. It displays ASCII and octal next to it. Let me check if DMA is initialized. Buffer, I mean that stuff. We missed the first packet because we don't have that stuff. I need to have it here. Is it DMA init structure? No, DMA buffer size. Okay, let me try to set it here. DMA channel. Okay. It's initialized, and then we miss a byte. So that's weird. How do I? We can do what we can do is we can change priorities, but I don't think. If the chip select, if the line is just a little bit slower, then we can have this behavior. Oh no. So how do we do it? We need to trigger it on DMA complete or whatever, and then just reset it. So we need a DMA interrupt handler. Set function. I mean we have the control over CS. We can add a delay, but I really don't want to, because the delay can be arbitrary. You're limited to your physical slew rate of the CS line, and if that is like different for some reason, you might get like, or the slew rate of, I don't know, your clock, and maybe the chip select is faster. Yeah, the proper way would be to trigger on DMA complete, just another interrupt, and not use that at all, only on falling edge reset the counters. So what we want is basically we want that without any overhead, really. In the startup, I have 2 microseconds added to after the but that's so weird. Why do we get a byte there? Okay, let's try to add duh, duh, duh. I will ask Gemini. What's the channel? DMA1, channel 4, 4 and 5. Hey, Tommy! I hope you are hiding. Are you living in a city or on the countryside? We are trying to optimize our code. Okay, DMA interrupts. Here we go. Here we go. We have some code for that. Spaces. I guess. Ay. I don't know if this is the ISR. Okay, it does look like the I. Here are the interrupts. Okay. SPI RX. Nice. It did even a flag here and it's volatile. So we can do while if okay, city. Yeah, that's dangerous. We have a friend that also lives where you come from. I don't want like to trigger any anything here, but and they live basically at the countryside, which is probably more safe than the city, huh? You're just staying inside all the time. Or I don't know if it's like we we get always some news, but only very limited from Iran. So I don't know what the current state is. Persia. Yes, let's call it Persia. Yeah, I already triggered. Ah! I need to drink. Oh, there is a major delay, I see. Hopping 20 different proxies. No, there is no booster bottle. It's diet. I don't have booster. And tomorrow is Feiertag. Your booster stash is amazing. How many? It is like 20 liters of booster that you got there, or more. Bottom. 35 liters! Oh. 35 half-eaten ripe tomato, yeah. Oh. Yeah, not only that, that's enough to drown someone. you can you can you can dissolve a body, a corpse, in that amount of booster. I thought a body. You know what? If you would empty that many bottles of booster in, did you get a good price for them? How much did you pay per bottle, or like the complete order? That's like 30 bottles of booster. All right, that's more or less the normal price. But did you pay like fund on top, or is it with fund? Ah, yeah, all right. Is this like delivery by Rewe or? Yeah, that's all right. Yeah, that's normal for 1.5 liters. You get like the half liter cans. Or you can get them from Netto, or you can get them from any. You can get them from Rewe Getränkemarkt, Tom Getränkemarkt, I believe. No, Tom. Is there a Tom Getränkemarkt? I don't know. But yeah, there are Edeka Getränkemarkt. Yeah, you can usually, but let me think. Oh no, I don't think so. It's Edeka, sorry. I'm not sure if I saw booster at Rewe. But it's Netto, and Edeka. I'm sure about that. They always have that. Yeah. All right. So it seems you like a booster. But yeah, you need to drink it cold. I don't know. It's like the sweet one with the sugary one only tastes good if it's really cold. But then it's good. Oh no! Yeah, the half-liter cans is what I. Yeah. Oh yeah. I mean, the Red Bull. Yeah. That's cool. All right. What did we do? I'm lost. I was in Persia. Complete. Yeah, we can do that. Let's do. RX complete. RX complete. TX. Yeah, that's cool. Even a great comment. Okay, let's upload and test, and build failed. Ooh. Oh. Ooh. Oh. Yeah, that's what you get. No. RQ. Did you mean DMA channel? Okay, now. Yeah, it has also taurine. With taurine and. Okay, so we have DMA channel 4 RQ handler, DMA 1 channel 4 and 5, and the assembly says, one. Do I need to predefine it? It's weird. Usually it knows the handler. Maybe it's not predefined. Alright, okay. And I will take it from here. Oh no, that's the other one. And let's predefine it. Oh, I see. We had it predefined. Oh. Here is the initialization. And boop. Oh. Wait, what? Oh. That's what's the issue. NVIC structure. Hä? Oi, oi, oi. Okay. We need X. Oh. Yeah, this is bullshit code. Okay, let's fix it then. We need this here. This is the handler. Now X. No, this is external interrupt. And because this not the handler, we need channel. Here is the channel name, not the handler. But where do I give it the handler? I guess. Let's hope for the best. I don't know, maybe the address is entered there, but no, wait. night. Good night, Basil. Here we go. That worked. What? We don't even need to pass like the callback function. It just worked. Okay. Let's see the debug output. Yeah, the message is complete. Perfect. Okay. So, is that? Yeah, okay, let's try sending 41. Six, 5. Oh yeah, that's 41. No, wait. Yeah, 65 ASCII is so confusing. That's 41. That's cool. That works. Okay, let's test again. I want to see that I didn't miss a single packet in the beginning, especially. Okay, so let's send one packet. Book. Here we go. Yes, it's there. Okay, let's clean up. And we should also, how do we test trends? Oh, we need to host. At least we're getting something right. We should be able to test now the host capabilities. If these are the right pins, okay, I maybe I will still split it. So this is I will put it in a new file. That's SPI hosts, and I will put it there. Oh wait, we are at SPI user, not user, client right now. New file. And add some documentation. I started to add version numbers to when I copy it across all the levels or whatever, so I always know which version it is. SPI DMA client implementation on SPI2 peripheral GPIOs. What was it? Let me check. Wrong. No. No, right. Huh? Huh? Oh, that's the main test. Here. Yeah, 13. CS is 12. CS is 12. Oh wait, it's B12? B12? Yeah, I think it was B12. Yes, B12. B12. Chip select, SCK is B13. Meso. Meso 14 and Mosi is 15. Meso 14. Meso 14. Mosi 15. Okay, so we know every detail about that, and it will just take, oh yeah, if def packet size SPI client packet size 16, and then let's clean it up. Yeah, let me just copy everything. If def, because we do the following. Oh yeah, 16 here, and if in that case we can just predefine it with a different size. Stupid C code. No template here. Okay, SPI2, that's what I want here, but I want also, yeah, we have the whole the host here. Oops. We'll try the host in a minute. I'm wondering how we will do the host though. We can try to use the host directly to change the LED color, but let me save that, and SPI2 void, how do I called it before? Init SPI client, yeah, that's my name. That's on GPIOB. SPI. Oh, we need DMA1. DMA1. Okay. This is so dangerous. One of these lines can basically jeopardize everything. Let's remove anything that we don't need. Yeah, let's enable clocks, pins. SPI peripherals. So in that case, we are overwriting a mode and an SS. So this is soft and the mode is here. Mode. Okay, and then that is still weird. I don't know why that needs to be here. Usually I would do. Hey, the hater! The 80, how are you doing? Wait, that's memory base address. Yeah, this is not what we want. This is also not what we want. Not what we want, not what we want, not what we want. Dear destination. Oh, LAN party. Yeah, that sounds great. Send some warm weather up here. It's currently a little bit colder. I still have the window open, but must admit I wasn't keen to go outside today. Okay, so these here priority and direction priority high. That's interesting. Okay, that's the it plays around with the priorities. So it's actually I want a higher priority. Not sure if that's good. Peripheral base, memory base. Direction, buffer size. Wasserschaden, what? You didn't say anything. What happened? Tell me about it. What? Did like a pipe burst, or did a pipe burst? In your flat or another flat? Oh no, this is the worst. If it was only a flat below you, that would be okay. Oh, terrible. And the people were out or what? Like at work or in on vacation. Oh, but you noticed and notified your landlord or what? Oh no. Oh shit. Yeah, okay. That's the worst. How did you notice? Was like dripping from the roof or what? I mean ceiling, not roof. Strange noises. Oh. Did loose adjusting for a building that had the rooftop. Oh. Got something from Amazon, thought it was the plastic wrap, but got wet soon. Loss adjuster. Okay. Alright, let me finish. Oh! Oh, that's nasty. Oh shit. Yeah, they like there where the cables run, like Kabelkanäle or something. Oh, yeah. Oh no. Yeah, especially if you have imagine you get um 400 volt or something out of the socket. You were able to transport the booster like loggers in Canada on the river. Okay, configure DMA channels. Now we need to check priority. That was maybe the reason that I just removed that. Peripheral destination source. Peripheral increment. What? Oh, there are so many options. Packet size. Okay. Buffer size. And we don't have packet size. We have SPI client packet size. Packet size. Okay, image structure, we don't change anything. RX data R. Okay, we don't need that. Normal. Okay. Priority medium. And then we do channel. Let's take it here. Peripheral base address, memory base address, direction. Okay. That chunk. DMA1. Yeah, DMA1. Okay. Rising, falling. Do we still use that? We use it on flag, clear, packet size. So that's initialized again. I'm working on the mega ultra cluster, not the mega ultra cluster with trying like to improve the communication to DMA. That's what the goal is right now. It's not very interesting, I'm sorry. We might, I don't know, maybe I will have another stream soon where we can implement something to show maybe on weekend, I don't know. Tomorrow is a public holiday here. Yeah, that's what we try. It's like, I mean, it's not straightforward like you would remember how to initialize that correctly. That's why I think we only need the rising edge here right now. So basically we can do that. Rising edge. Only for resetting peripherals after. Oh wait, is that even good? I'm not sure if that's a good thing. Didn't we have like a lost byte before? Setting. But it worked, okay. I know that there is like to do be sure message is complete. Might not be complete. So that's, if we didn't receive the last byte, okay, we can test that. We should test that. We can test that. I think that the code is still running. Yeah. We can test that by adding last byte like something odd. 6, 7. Here. Let's see. Yes, it's complete. Okay. No worries whatsoever. Ah, nice. Okay. Having like tools like this is so cool. It only takes like 10 minutes to set this up. Maybe adjust a little bit. But it's so convenient in the end to test and debug like that. Okay, let's kill it and continue with cleaning that up. That's the DMA. we don't need that. Oh no, oh no! I don't need to change it here. Ah, I did it already in the other one. Control Y. Okay. Huh? Okay, that's what is host? No, where is my client? Here, this is where we editing. Okay, with comments. That's handled correctly. Okay, host packet routine, blah blah blah. That's be sure DMA is finished processing message. Okay, volatile Rx complete. And that's the main, we don't need that. We can basically do that. Wait. Here is okay, that's include SPI client. Okay, and then we don't do anything of that. We hide everything and SPI client. Client packet size. Okay. Now I will also add the host, and let's just route messages to maybe we can change the LED if we have the host working as well. Let's do SPI host. Now we have it's split, which is cool. Okay, and now let's do all the things that we that we did before. Okay, maybe we need that. Oh, voila. this is something we will add functionality to the host in a second. Okay, so we need different RQ handler. Then we enable clocks remap. We need GPIO host is oh no, 5K. Oh, do you have like insurance for that? I would all blame like on insurance. It has most probably something to do with the power fluctuations. Yeah, it's probably a cap. I mean, we fixed on stream like a screen where cap blew. Yeah. Oh, hissy noises. I think it is a broken cap. If you open it, you can see if there is like bolt. Yeah, that would be easy. Yeah, keep me updated. I'm invested. Okay, SPI host is on B alternate SPI 3 B 345 SPI 3 and this is on B. There is three, four, five. SPI3 remap enable. Do I have that exactly like that? There is no remap. Interesting. Oh, interesting. I did it a different way, but I think I had this here. It must be in the old one as well. There's no... I can't see it. I know I used it as well. Okay, enable alternate function. Yeah. Three, four, five. and we have chip select SPI clients prepare GPIO. Yeah, that's what we do here. That's, I will put it in extra function here. Void init SPI CS pins. People hate me for that. I should change my naming conventions. Not camel case anymore. I don't care. I'm too old to care. I don't like the underscores, but oh, this is what you fixed? Cool. And that's the measurements or what? Replacements. Cool. Yeah, sometimes it can be easy. Yeah, I have also, no, I have an frameless, that's from OBS. I have the chat in OBS, that's okay, we need those functions here. SPI clients. Host clients. Yeah, 32. And we had SPI host packet size. Host. If I can make it, a goal for today would be to make that work with DMA and everything, then I'm like really good. Can basically finish everything tomorrow then. Init SPI pins, which will happen basically SPI CSD. Here. Enable clocks, pin remapping. So that's what I wanted to change. Okay. CS pins. Okay, that's configure SPI 2, 3. That's what we don't need. SPI host, interesting. SPI 2. Okay, SPI 2. Then SPI 3 DMA. Then there is this enable. And then configuring DMA channels. Packet size. That's RX, that's TX, and that's easy to remove. Then we have we don't need that anymore. That would be the interrupt for CS we are controlling. Are we bored yet? Yeah, we are. We need something for DMA. Oh yeah, that's why how I DMA channel. Four, 5, we need the DMA channel 1 and 2. So actually SPI 3, that's interesting. It uses DMA 2. No, that's alright. Then we don't need DMA 1 here. DMA 1. Yeah, external interrupt trigger is not not needed. Then DMA channel DMA 2 channel 2 on DMA 2 channel 1. So what we want now is to first of all oh, good question. Let me check that. NVIC. Nested vectored interrupt controller. Oh, it gave me. Okay. I think it was what? Yeah, DMA 1 channel. Okay. So let's just do that. channel 4. Uh-oh. I have a copy paste error here. Channel 5. Yeah. That's anyways, that's not our 1 and 2. Need to fix it here as well. Copy paste. Nobody caught it. What? Okay, 2. 1. 1. Set priority. But it should be triggered, like both should be triggered more or less at the same time. We have both 16. At some point, if it's not like receiving and transmitting sizes are different, then maybe. But why should it? I mean, it's always the host is always dictating the size, unless it can inspect the packet already. Like imagine if it transmits a packet of 16 bytes and it knows it checks after it's finished transmitting, the buffer for receiving is bigger. When it's done transmitting, it checks basically it checks if like what the length of the receiving packet is, like the first byte maybe, like we intended before, and then like just triggers more clocks before it turns off CS. All right, it seems like my brain is very mushy already, so let's finish this, and then if I see that we can forward a message using host, that would be amazing. I need to fix these here. This is not good. SPI 3 TX complete. Which one is TX? Oh, I don't know. Oh wait, that's DMA channels. We know that. It's here. That's RX TX. this is let's be sure. DMA channel 1, RX is 1, okay, RX and TX. Okay, so we need oh, interesting. This is host transmit packet dispatch routine. Let's check how that works, but I want this interrupt handler is not necessary anymore. Actually, this would be while DMA flag. Okay, so this is how you can basically stall until it's like with polling, but if you want to do it in the background, it will be easier. So we can do set CS. Okay, I will copy that into the main, or crop into the main, and SPI TX complete can be here. SPI3 TX complete is 1, and this is EMI2 T channels 2. Hey Robin. Channel 1. DMA2. I don't know. This is this is also not right. We want DMA3. No, DMA2. Wait. That's DMA, not SPI. Okay. DMA. Okay. That's that. Packet size is basically host SPI host packet size. Host packet size. And we have CS this able CS 0. That's our LED. Yeah, you are here, Robin. You arrived. Enable CS as a blah blah blah, that's that. Whoop. Let's check. Yeah, it's all right. DMA enable, okay. Channel 1, 2, get flag status. We can do the same, we can test it with, okay, I want this here. And also enable CS delay. I had like 2 microseconds. We need that for the little MCU. Before we do anything else. All right. That's that. Let's just forward whatever message we get. Oh. Bye. DFGA. We will test in a second if you have some spare time, but I guess SPI 3TX buffer will be basically 4. We will just forward the message SPI to RX buffer. Okay, interesting. This will be interesting because we will forward just the message when we receive one as a client. So, and then check. Hey Robin. Huh? Now you're on Twitch as well. Okay. Init SPI init SPI host. And this we need to rename the function also. It's not. Okay. Should we test it? Okay, let's record that moment of truth. It will problems. Packet size. Oh yeah. Oh no. SPI client. Are we in client? Yeah. Build fade. What else? Even more packet size. Yeah, I just renamed the variable more. Nope. That's it. All right. Should we just debug it and then see what happens? It triggers a breakpoint. Oh, I see here a breakpoint. Oh, that's not a good sign. Oh yeah, I don't call the transmit packet. That's why the breakpoint was moved. SPI complete, and then I will. Oh, what? Huh? Okay. That's that. Now it should be debug. Coding is time consuming. What? Why? It's optimized away. This is volatile. Oh, come on. I don't know. Why is it? Yeah. Okay, let me just run it. Ah, that's weird. Why is it always complete? Okay. Is it done yet with doing weird stuff? Okay. Let me try again. Okay. We get something. We got the packet. This was initialized 0, yeah, it was. Okay. So why do we end up here? SPI hosts. Oh, transmit didn't finish. Oh, we hang here. No good. Okay, let's do this. What was the variable name? Hosts. Oh, that's the wrong one. That was infinite looping here. Ah. Yeah, we need that one. And the other one needs to go. Yeah, we need to restart the code. Okay, so that's why it didn't work. Okay. 0. Oh. Do that. Y. TX. All right, let's start again. What did I do? What? Still sees a problem, redefinition. Huh? Where's the other one? Okay, yeah, that's weird. Okay, good night. And I will show you here the masterpiece. Here is it. Host, transmit. Okay, let's see if we can change the. Okay, for the record. We have this is annoying. We have DMA code complete. Let's send like full white to my LED. Should we turn on the camera? Boop. They're in the center, behind this wire here. It's so weird. Wire, go away. Here. Sand. Nope. Didn't happen. Didn't happen. Okay, transmit packet. Let me check what kind of packet we receive. Boop. TX buffer is nothing. RX buffer is nothing. What? Okay. Why though? That's so weird. Oh, wait. We need SPI2 RX buffer. Oh no. No, you got it. Gustafsson. Well, Lene Gustafsson. Yeah, you got it. Yeah, downloaded it is. Did we upload it? Yes, I think. This changed. Okay, let's try again. Okay, moment of truth. Let's try again. Bloop. Breakpoint triggered. Oh, we see a message. Let's forward it. Ugh. Nothing. No. I thought it's sent. Okay. SPI. We need like our TX transmit isn't working properly. Transmit packet. Are we hanging? No, we're not hanging. It actually transmitted here. So it is probably low as well. No, it isn't disables here. Why is it? It's triggering me. I can set this breakpoint. Okay, let's do it. Send again. Okay, let's check for the transmit buffer. TX, SPI TX buffer. We have the message. It's complete. DMA2 channel 1. TX complete. Okay, let's just run. Now it's gone. And it's probably complete. Yeah. Yeah, it's complete. Okay, so it's supposed to be transmitted, but I don't know if I receive it though. That's weird. Okay, let's check again this SPI host if I'm doing the right initialization comparing with the other one that I did before, because I think okay, I have SPI host here. This is how I initialized it before and it worked. So this I'm not using the remap, I'm using alternate function according to the time. Warm white. Pin 3, 4, 5. Push pull 3 alternate function 4 3 4 5 floating. Yeah. I don't use this though. Why ever? I could, can I scope it? Yes, I can scope it. So I can see if we get anything out there. Yeah. our scope, at least like the chip select or whatever we can do there. Not chip select, but the clock. If we see a clock, then we know, okay, something's transmitted, maybe. This will be hard because I need to like touch my botched resistor or something to be able to do that. Okay. Did we already update it? Oh yeah, we did. I was so tired that I don't know what I'm doing anymore. Okay, I do a single. Stupid, because I need to touch it first. Okay. We have breakpoints. Let me check if we trigger any breakpoints here. Boop. I think we have all breakpoints disabled. All right. Let's test if we even get stuff. Yeah, it's triggering. All right. Then let's test the output on the scope. Prepare the page. Okay, there is something. I see the data though. There is actually the data that I expect to see, I believe. Wait a second, what is that in the end? Okay, let's try again. Oh, is this the clock? Okay, that's the clock. Okay, then let's take... No, wait, that should be Miso or Mosi. Okay, let's try again. Yeah, No, that's Miso or Mosi. I don't know which one yet. Okay, that looks 10. No, that's not meaningful data. Oh no, it is. Okay, so we have this is 8, this is 10, this is 8. Voltage level is quite high even. 4 volts. Why is it so high though? Might only look like that. Then no, that looks correct. Oh, wait! The LED is also white. Why is the LED white? Huh? Huh? Okay, let me change the color. Nope. One arrived or what? A packet arrived. Yeah, this one LED, but no, I don't know why this is not working. Oh. Okay, let me check something. What speed am I using here? That's also a difference. I mean, I might have used a clock rate that's quite high. Prescaler is 60 now, that's alright. Yeah, no, I used we can try slower rate, and for that case yes, that's what I try. Lowest clock, but it's not like also not the fastest. I mean, the signal looks really clean. Nope. It's not the clock either. Okay, let me compare the data. Duplex master, edge soft, edge low, master prescaler, first bit MSB, polynomial 7, all the same. Weird. Oh, it's all we can't swap it anymore. This is like hardware given. It's all the same. And why would it work like one time? I think either the MCU, the little one, might be in a weird state. We can reset and try again. Yeah, we can try that. Yeah. Oh. Oh. Okay, let's turn off and on. And restart the debugger. Now the LED is in a, the small one is in a state of, maybe I zoom in. What? Ah, yes, it does, because that's the start state. I didn't want to draw a lot of current in the starting state to have, like, it means it's red. Here we go. We have 4K, so we can zoom in like crazy. Crazy girl. Oh, look at that. All right. Okay, let's send state. Oh wait, we need to. No, we don't need to initialize anything. It's not changing. It should be blue. This editor's weird. No, nothing. Oh, we are in a breakpoint. Okay, we are in a breakpoint. Okay, let's see. Let's release the breakpoint. No, nothing. Let's try again. Breakpoint. Let's see the message. Oh, the message is mangled. It's shifted by 1 byte. We have the weird state. Okay. So actually it might be the issue with the DMA on the receiving side. Okay, let's start over. And see if we can get a full message. The message is full. Okay. Bloop. Yes! It turned blue! Alright. I turn off the breakpoint. Let's turn it white. Nope. Now it's broken again. Okay, let me check if we have some weird shift. Whoop. Packet looks alright. Nope. Didn't go through. I don't know why though, because the packet looked right. So maybe the little controller is in a weird state. Let me try again. Here, if that we get only a weird state in the beginning of the transmission. Here we go. Nope. It's now again weirded out here. Nope. should be, the message looks good. So let me power cycle again. So might be the little MCU that's broken. I mean, like in a weird state after power up. Yeah, it's powered up now. Let's just send something. The byte sequence looked alright, but it's a weird state. It sometimes works, sometimes it doesn't. Okay, if I spam the message, yeah, okay. Yeah, it's not very reliable. If I spam the message, let's set it to wide. Send it multiple times, now it went through. Like on 4th try or something. Boop! 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, 6, 7. It thinks, it takes too long to think. Alright. Okay. Yeah, I think the issue is not on the side of what we can do is still we can add a longer delay for the CS because everything is so fast. Here, let's make it safe and add 10 microseconds for any slew rate weirdness. What I'm wondering is, I was never able to place the breakpoint here. It's really weird, like it would be optimized away. No, same. It doesn't matter. The delay doesn't matter. Yeah, I need to click several times. Yeah, it doesn't do anything. When I reboot it, it will not work instantly. It's 2 times. I needed to click 2 times, 3 times. But DMA works, at least in one direction. I don't know if it works in the other direction as well. That would be cool to see. But I think this is enough for today. Yeah, I need to do more on the firmware of the little MCU, and then check the transmission back, because we should have on the host side also receiving stuff. So I can implement that and have a full duplex communication. All right, thank you everyone for watching. It was cool, boring, and coding streams are always boring. Lab will move over to the other room. We have more space, bigger workbench. And I'll see you soon. I don't know if I can make it maybe this weekend. But I will be busy with editing video. Bye bye everyone. Good night.